Question number 4 on problem set 5 says Jocelyn and Kelly built rockets from assembly kits and are going to launch them at the same time to see who flies higher. Jocelyn's rocket height is given by the equation J of t equals negative 16t squared plus 180t. Kelly's is given by that other equation, negative 16t squared plus 240t. Part A wants to know the maximum height for each rocket. So we've got a parabola here. The maximum height, the biggest y value, would occur at the vertex. Notice the parabola opens down. So the biggest height's at the vertex. So we can do negative b over 2a to get the vertex. That would give us the x value, which is a t, it's a time of the vertex. So negative 180 over 2 times negative 16. Gives us 5.625 seconds to reach the maximum height for Jocelyn's. It doesn't want to know how long does it take to reach its max height. It wants to know what is the max height. So this is the time it takes to reach the max height. So we can just plug that time into the equation to get the maximum height. So I'm going to store it as x and then type in negative 16x squared plus 180x. So Jocelyn's reaches a maximum height of 506.25, and that is measured in feet. We do the same thing to get the max height for Kelly's, 240 over, or negative 240 over 2 times a. I get 7.5 seconds. And then negative 16 times that squared plus 240x gives us Kelly's reaches a max height of 900 feet. Part B wants to know how many seconds apart does each rocket land. When the rocket lands, its height off the ground is 0. So we can find the time it takes Jocelyn's rocket to reach the ground by setting the height equal to 0. This is pretty clearly a calculator problem since I'm using it over here. So you can solve that by graphing. I'm going to solve it by factoring out a t. Set each factor equal to 0. So it's on the ground at time 0, which we already knew it started on the ground. Or when negative 16t plus 180. That should just be 180, not 180t. Sorry, factored that t out. So we have 180 divided by 16. It gives me 11.25 seconds for Jocelyn's rocket to reach the ground. We do the same thing with Kelly's rocket to find how much time it takes hers to reach the ground. And hers is on the ground at 0 seconds, which makes sense. Or when negative 16t plus 240 is 0, which occurs at 15 seconds. The question wants to know how many seconds apart do the two land, so you can subtract the 2, and we get 3.75 seconds. Part B wants to know part C, to the nearest tenth of a second, what was the difference in time for the two rockets to reach their respective max heights? Well, it took Jocelyn's 5.625 seconds to reach its max height, and Kelly's 7.5 to reach its max height. So it just wants the difference in those times, rounded to the nearest tenth of a second, which would be 1.9 seconds.